Welcome to the next lecture of Math 210. In the previous lecture, we were discussing an example of the power series method. Let's start that example again. We had to solve an ODE using power series method about an ordinary point x equal to 0. So the ordinary point was x equal to 0, and we have to solve this ODE using power series method. So in order to solve this differential equation using power series method, what we usually do, we assume that the solution is of the form power series y of x is equal to summation n from 0 to infinity Cn x minus 0 whole raised power n. Okay. Now, what do we need here? We need the second derivative of this solution, and by inserting these assumed solution in the differential equation, we try to find these constants, unknown constants Cn. I told you in the previous lecture. So what we need here, we need to find its first derivative, because we need here second derivative. So first derivative is n from 1 to infinity n Cn x power n, x power n minus 1. And in the second derivative, the summation will start from 2 to infinity. I told you in the previous lecture why we increase the summation, index here. N into n minus 1, Cn x n raised power minus 2. Now we have these three expressions, this one and this one. We insert here in this differential equation, and we try to find the constants, these coefficients, unknown coefficients, Cn. Let me add the people. Now, inserting these things here into the differential equation, what we obtain n from 2 to infinity n into n minus 1 Cn x raised power n minus 2 minus plus x times n from 0 to infinity, because here we have y. So it is Cn x raised power n equal to 0. Now we can take this x here inside this summation, because there is no n involved here. So let me add the people. What we do in the next step, we can take this x here and we can put here n plus 1. Okay. Now here we need to find the constants Cn, and for that we need to take common the summations. We have to combine these two series. We obtain two series. We have to combine these two series. How do we combine them? We need to take common summation term and the x powers term, so that the remaining terms can be combined, and we can obtain some kind of relation which can give us the values of unknown constants Cn. The first thing which you should observe here, whether each term of the series start with the same power of x. Now, if we put here 2, what will be the power of x here? 2 minus 2, 0. So this series start from x power 0. Now let's come here. This series n from 0 to infinity, when we put n is equal to 0 here, we'll have x power 1. Okay. So the second series starts from x power 1. So what we do here, either we open one term of this series or this series. So let me separate the first term or open first term of this series so that the powers of x in both series starts with the same power. So if we put here n is equal to 2, what do we get here? 2 into 2 minus 1, c 2x power 0 plus summation n from now 3 to infinity. We have opened only the first term. It is now n into n minus 1 cn x raised power n minus 2 plus n from 0 to infinity cn x raised power n plus 1 equal to 0. Yeah. Now, what we do, this term is separated. We can find the value of coefficient separately from this term. Now, we need to now concentrate on these two series. In order to take the summation, the sum outside these two series, we need to combine these two series, okay? What we do, we assume that this is series 1 and this is series 2. Okay. Now, the second step is we have to make the powers of x identical in both series. Powers of x identical in both series. How do we do this? For example, if we consider first series S1, if we substitute n minus 2, you can say that let n minus 2 is equal to some other thing k. Now we are going to make the exponents of x identical. How do we make them identical? We put this n minus 2 is equal to some k, and in the next step, we'll let n plus 1 is equal to some other index m. We'll consider it after this. So here we assume that n minus 2 is equal to k. Now we are going to change the index of this summation. N starts from 3. If n is equal to 3, then k is what? Then k is, अगर यहाँ पे n 3 put करें तो k की value क्या आएगी? It is 1. And if n is infinity, then k is what? It is obviously infinity. And from here, we can see that n is what? N is k plus 2. Now, inserting all these substitutions into this series 1, what do we obtain? Let me write it here. In S1 is now, before it was n from 3 to infinity, n into n minus 1, cn x raised power n minus 2. Now, after substituting or after using these substitutions, what do we get? Now, this index of summation has been changed to k from 1 to infinity. N is equal to what? N is equal to k plus 2. And n minus 1 is k plus 2 minus 1, k plus 1. Cn, n is now what? N is equal to k plus 2 and x power k. Now, the series 1 has been transformed into this series by using this substitution. Now, let us consider the second series. Now, consider S2. S2 is what? N from 0 to infinity, Cn x raised power n plus 1. Now, what we substitute now, n plus 1, let n plus 1 is equal to m, maybe. Now, we change the indices here. If n from 0 to, if m is 0, then m is what? M is 1. And if n is infinity, then m is what? It is obviously infinity. And also, what is n plus 1? It is m. And n is what? and n is what? It is m minus 1. Now, using these substitutions here in this series, we can write that S2 has been transformed into now m from 1 to infinity. Cn, n is what? M minus 1 and x power m. Now, you can see that after these transformations, after these substitutions, the two series, S1 and S2, if we use them into the original expression, which was here, now we are going to use the transformed S1 series and S2 series. We are going to put them here in this expression, in this equation. If we use these two new transformed series here, we can write 2c2 plus summation k from 1 to infinity, k plus 1, k plus 2 times c k plus 2 x power k plus, now this one S2 is what? Summation m from 1 to infinity c m minus 1 x raised power m equal to 0. Now, one thing you need to remember that in any series, this index, summation index, is dummy index. You can replace this dummy index with any other alphabet. Means if here we have k from 1 to infinity, we can write here m from 1 to infinity, m c m x power m, so that the both series, they become identical. Or you can change this index. You can put here, you can replace this m with k from 1 to infinity c k minus 1 x power k, because the index in any series is dummy. So we can write here c2 plus summation k from 1 to infinity, k plus 1, k plus 2, c k plus 2 x power k plus summation k from 1 to infinity, c k minus 1 x power k. We have changed the index of this second series so that they become identical. Indices become identical. Now you can see that in both series, the summation term here and here, their index is same. They start from 1 to infinity. It starts from 1 to infinity. So we can take this term, this summation outside these two terms. Similarly, here x power k, here we have x power k. So the exponents of x are also identical. So now we can write this thing 2c2 plus, we can take this common, k from 1 to infinity. Yes, and then common k plus 1, k plus 2, ck plus 2 plus ck minus 1 times x power k equal to 0. So what we have done here, we have taken out this summation term and this x power k, both these two terms. And the remaining terms are basically, we have written them inside this bracket. Now, what we have done here, we have combined the series, the two series, into a single series. Now, from here, we can compare the coefficients of same powers of x on both sides. For example, the right-hand side, we can write it what? 0 plus 0x plus 0x square plus so on. Now, the coefficient of constant, this is your constant term, that's basically x power 0. The constant term will be compared to 0 here. And the rest of the series, because here we have x power k, so the every coefficient will be equal to 0. Because On the right hand side, we can write this kind of polynomial series with the coefficients 0 with each power of x. So now comparing coefficients of these two series on both sides, what do we obtain here? We obtain 2c2 is equal to 0, and then k plus 1, k plus 2, ck plus 2 minus plus ck minus, was this? ck minus 1. This is equal to 0. So we obtain two equations, C1 and this one, 1 and 2. Now from the first equation, we can obtain that C2 is 0, this one. And from the second equation, we can obtain ck plus 2 is equal to what? Negative ck minus 1 whole divided by k plus 1 into k plus 2. This one. This is called a recurrence relation, which is called recurrence relation. Recurrence relation help us to find the unknown coefficients. Here you can see that we cannot take the value of k 0. So k should start from 1 at least. So k is 1, 2, and so on. So this is your recurrence relation. Now inserting the values of k. For example, for k is equal to 1, if we put k is equal to 1 here, what do we obtain here? It gives us C3 is equal to minus C0, C0, or नीचे क्या आ जाएगा 2 into 3, 2 into 3. So this is the value of C3. Now, when k is equal to 2, we obtain C4 is equal to negative C2 divided by 3 into 4. But remember that C2 is 0 here. If C2 is 0, then this will become 0. C4, 0. Similarly, for all even numbers, when we put k is equal to 4, we'll have 6 here. So here we'll have C4, and C4 is 0. So all the coefficients with even subscript, they will all be 0. Okay. Now we can only find the coefficients with the subscript odd. Okay, with odd subscript. So when we put k is equal to 3, we obtain C5, and it is equal to what? C5 is negative C3 divided by 4 into 5. Okay. Similarly, and so on, we can find many other constants, and we can write finally the series now. If we find 8 to 10 constants here, then we can write the series. We assume that what was the initial assumption of the series? The series was, we assume that series y of x is equal to what? It is summation n from 0 to infinity, cn x power n. And we can open it, if we open the summation here, what do we obtain here? C0 plus C1x plus C2x square plus C3x cube plus so on. Now inserting the values of non-constants. C0 is basically unknown. We cannot have the value of C0, it is unknown. So C0 remains C0 plus, what is the value of C1? C1 is also unknown, so it remains C1. Okay, because the constants here, C2 is 0, we can find the constants from C3, 4, 5, and so on. We are unable to find C0 and C1. So C1 remains C1 here, plus C2 is 0, plus C3 is what? C3 is negative C0 divided by 2 into 3, x cube, plus C4 is 0, plus C5 is, it is negative C3 divided by 4 into 5. So it is negative C3 divided by 4 into 5. But we know that C3 is what? C3 is this one, and it is basically negative C0 divided by 2 into 3. So in fact, this constant becomes what? Minus into minus, minus 1 raised power 2 divided by 2 into 3 into 4 into 5. Okay, so this is your C5. So we can directly write it here, negative 1 raised power 2 divided by 2 into 3 into 4 into 5, x power 5, and plus so on. Okay. So now if you look at this solution, there are certain terms which involve C0 and other terms they involve C1. You can see the detailed solution in my notes. I have written many terms in my notes here on the page 33. You can see this. Is there any question? Shouldn't the coefficient of C5 also be multiplied by 0? Yes. Here we must have C0. Thank you. And similarly, we can find many other constants. After finding these constants, certain terms involve C0 and other terms they involve C1. Okay. Now, after rearranging these terms and taking C0 common, we can write C0 1 minus 1 by 2 into 3 x power cube plus 1 over 2 into 3 into 5 into 6 x to the power 6 minus 1 over 2 into 3 into 5 into 6 into 8 into 9 x to the power 9 plus so on. This thing and plus C1 times x minus 1 by 3 times 4 x power 4 plus 1 over 3 times 3 into 4 into 6 into 7 x to the power 7 minus 1 over 3 into 4 into 6 into 7 into 9 into 10 into x to the power 10 plus so on. So we obtain these two series by rearranging all these terms in this expression. We can take C0 from common from the terms and C1 from the other terms. So we obtain these two in fact terms. Now what is this? The coefficient of C0. C0, this thing is a series, and this one, which is along with the C1, this is another series. So we call it C0 Y1 series, which is along with the C0. This we call Y1 series, and the other one C1 Y1 series. Okay. So this is your general solution, and I hope you know that the solution of second order differential equation, its general solution is basically what? It must involve two parameters. Okay, two parameters are C0 and C1, and the first solution is Y1. Second solution is Y2. Now the difference is that previously we obtained Y1 and Y2 as some functions. Now here in this case, y1 and y2 are basically two linearly independent series. They are now series. So these two solutions are basically series solutions of the given differential equation. But the solution is basically a family of two parameters. I hope you get it. If you have any question, you can ask me. The next step. जी जी बोले.
सर पहले तो जब हम K2 पुट करते हैं तो हमने कहा कि C4 equals to 0 आ रहा है.
Sir, can you explain why C4 is 0? देखिए यहाँ पे C4 is what? It is minus C2 divided by 3 into 4. Sorry.
Sir, isn't it minus C1?
Just a second. It is when we put K is equal to 2, we get 4 and 1. Yes, here we must have 1. So it is my mistake, sorry. So here we have C1. So the coefficient of here at 4 is on the board 2. Here, the coefficient of C4 is what now? It is minus C1 divided by 3 into 4 times x power 4. Okay. Only C2 will be 0 here. Okay. और नेक्स्ट में C5 में फिर क्या हो जाएगा 2 हो जाएगा C5 का कोएफिशिएंट 0 होगा ठीक है सो दिस इज माय मिस्टेक सॉरी यहाँ पे C5 का कोएफिशिएंट 0 होगा ठीक है C5 और यहाँ पे क्या आ जाएगा C2 होगा सो C5 का कोएफिशिएंट 0 होगा so if we go back towards certain coefficients will be 0 due to this C2 so C5 का कोएफिशिएंट यहाँ पे 0 आएगा ठीक है C5 का कोएफिशिएंट 0 होगा ठीक है अब आप देखें C2 का कोएफिशिएंट 0 है C5 का कोएफिशिएंट 0 है फिर C आई थिंक 8 का कोएफिशिएंट 0 होगा ठीक है so C2 if C2 is 0 C5 is 0 then C8 will be 0 and then C11 will be 0 and so on all these coefficients in this series will be 0 or you can see here in the solutions as well we do not have x square there is no term of x square here because the coefficient of x square is 0 यहाँ पे x cube है x6 है x9 है x2 का कोएफिशिएंट नहीं है फिर x5 का कोएफिशिएंट भी दोनों सीरीज में नहीं है because x5 x power 5 0 हो जाएगा because C5 is 0 because the coefficient of x5 is 0 x8 is 0 x11 is 0 because all these coefficients are 0 so these powers of x will be eliminated from the original series and some of the terms will involve C0 and some of the terms will involve C1 after taking C0 common and C1 common we obtain two series I think it's now correct if you have any further question you can ask me or some other further correction is there any other correction in the solution I hope no okay now what we can do further we can write these two series in the form of a summation by finding the journal terms of these series now let's analyze these two series separately now we can write y1 is what is the first series and it is 1 minus 1 by 2 into 3 x raised power cube plus 1 over 2 into 3 into 5 into 6 x raised power 6 minus 1 over 2 into 3 into 5 into 6 into 7 into 8 into 9 8 into 9 and x power 9 plus so on okay now we need to generalize this series and we need to find basically it's nth term or the general term. अगर आप देखें इसको हम सेपरेटली हर टर्म को हम क्या करते हैं जनरलाइज करते हैं, ठीक है. फॉर एग्जांपल हाँ, यहाँ पे मैंने काफी एक्सप्लेन किया हुआ है इसको, ठीक है. सो दिस वन, अब समेशन जो है आइदर इट स्टार्ट फ्रॉम जीरो और समेशन इंडेक्स इट स्टार्ट फ्रॉम जीरो और फ्रॉम वन. You can see a pattern here starting from the second term and so on. But first term is out of this pattern. What is the pattern? आप देखें, अगर आप देखें साइन, सबसे पहले देखें साइन इज अल्टरनेटिव. यहाँ पे प्लस है, सॉरी यहाँ पे माइनस है, प्लस माइनस प्लस एंड सो ऑन, ठीक है. सो वी आर नॉट राइटिंग द फर्स्ट टर्म इन द समेशन. द रेस्ट इज all the other terms they involve, they are having some similar pattern of numbers. Sign is alternating, so there must be 1 raised power n in the general term. When we basically put the values of indices and from 1 to infinity, when we put n is equal to 1, we'll get minus 1 raised power 1, we get negative. And here, when we put n is equal to 2, minus 1 raised power 2 is plus, so we'll get plus here. So whenever in a series the sign is alternating, we have to add this factor in the general term. The next thing is, if we start the summation n from 1 to infinity, okay, when n is 1, minus 1 raised power 1 is negative 1. When n is 2, minus 1 raised power 2 is plus. So sign is alternating now. Now here you can see that x power 3, x power 6, x power 9. So it also has a pattern, and the powers are basically the multiples of 3. How can we write this? We can write here x raised power 3n. When n is 1, we obtain x power 3. When n is 2, what we obtain? X power 3 into 2, 6. And when n is 3, we obtain 3 into 3, 9. So this is how we can generalize the powers of x. Now what remains is the denominator, 2 into 3, and then 2 into 3 into 5 into 6, and then 8 into 9, and so on. How can we generalize this? We can write here 2 into 3 into 5 into 6 into so on. What will be the general term here? The first term is 2, and then 5, and so on. आप इसको इस तरह देखें, 2 into 3 है, and then 2 into 3 into 5 into 6, and then 2 into 3 into 5 into 6 into 8 into 9, ठीक है, and so on. आप इस पैटर्न को देखें, आपके पास सबसे पहले 2 into 3 है, and then how does it increase? 2 5 हो जाता है, 3 जो है वो 6 हो जाता है, ठीक है, and then from 5 से 8 आ गया और 6 9 हो गया. So कितना गैप है इसमें? 2 to 5 3 का, and then 3 to 6 कितना डिफरेंस है? 3 का. So basically in each first term यहाँ पे 3, if we add 3, we obtain this, and if we add 3 here, we obtain the second number. So this is the pattern in the denominator. So we can generalize and write here 2 into 3 into 5 into 6 and so on, and 3k minus 1 into 3k. Yeah, this thing. Yes, absolutely correct. So this is basically the general term of the first series. In order to generalize, in order to write the nth term of the series, you have to look at the pattern of each term. Okay, this is your basically your expertise, how you can write the journal term of any particular given series. You have to what I suggest you to do, generalize each term separately. जैसे कि यहाँ पे हमने पहले देखा कि sign is alternating, so we can add this factor, and then we generalize the powers of x, ठीक है, and then we generalize the denominator terms. So you generalize them separately. I hope you can do it. Now, if we know this general term of the series, then we can check its convergence. Because in order to check the convergence of the series, you need to know the general term of the series. So here now, what is this? This is your series, okay? We need to check the convergence of this series. How can we check the convergence? We know that the general term is basically, चलो यहाँ पे लिख लें, convergence. Convergence check कर लेंगे हम, ratio test apply करेंगे, ठीक है, and then we can find the interval of convergence and radius of convergence, obviously. तो convergence check करने का क्या तरीका है? Ratio test. We apply ratio test here. What is ratio test? Limit n goes to infinity, mod of cn plus 1 divided by cn. ठीक है. Now, what is cn plus cn and cn plus 1? This is your cn. Okay. This is your cn. Now, writing cn plus 1, n goes to infinity. What is your cn plus 1? It will be minus 1 raised power n plus 1, x raised power 3 into n plus 1, whole divided by 2 into 3 into so on into, you have to replace here k by n plus 1. Okay. So what do we obtain here? 3 n plus 3 minus 1, it is 3n plus 2, and then 3k plus 1 here, 3k plus 3, not kn. Here n. Okay. So this is your cn plus 1. Now whole divided by cn. Now what is cn? Minus 1 raised power n, x raised power 3n, whole divided by 2 into 3 into so on, into आपके पास क्या आ जाएगा? 3n minus 1 into 3n ये आ जाएगा. अब यहाँ पे देखें, if you have 3n plus 2 and 3n plus 3, इससे previous वाली term क्या होगी? What will be the previous term? Here, it must be this one. 3n minus 1 into 3n into 3n plus 2 into 3n plus 3. Okay? So this will be your ratio cn plus 1 divided by cn. Now you can see that we can cancel x power 3n with x power 3n and we'll have x power 3 here. Okay? And minus 1 raised power n plus 1, minus 1 raised power n, ये n और n cancel हो जाएगा, we get minus 1 power 1. And all these terms until here, this one, these will be cancelled out with these terms. And what we are left with only this term in the denominator. Because all these terms, this will be cancelled out with this, and minus 1 raised power n will be cancelled out with n, and x raised power 3n will be cancelled out with 3n, and we'll left with x power 3 here. So what we are left with equal to limit n goes to infinity, minus 1 times x raised power 3 divided by 3n plus 2 into 3n plus 3. This one. I hope you get it. Now, n is in the denominator. If we apply limit n goes to infinity, all this thing will go to 0. This whole expression will go to what? 0. Now, in a convergence test, in a ratio test, if you obtain a limit L, this is your limit L. Now, the ratio test tells us that if this L is less than 1, then the series is convergent. Now, the limit is 0, which is less than 1. So this series is basically what? It is a convergent series. Okay. What will be the interval of convergence or radius of convergence in this case? Since we obtain this whole limit 0, and this limit is 0 for all values of x. Whatever the value of x here we put here, this series will be, so, or this term, this ratio will approach or will go towards 0. Whatever the value of x. If this series is convergent for any value of x, then what does it mean? That the given series is convergent for all x belongs to R. R is what? R is set of real numbers. Means this series is convergent for all values of x. For all values of x means all real numbers. ठीक है? अगर इसका interval of convergence क्या होगा फिर? Interval of convergence क्या होगा? The whole set of real numbers. And radius of convergence क्या होगा? Set of real numbers का radius क्या होता है? It is infinity. So interval of convergence is minus infinity to plus infinity. And radius of convergence is what? It is infinity. Because this series is convergent for all values of x. I hope you get it. If you have any question, you can ask me. Similarly, we can, we have checked the convergence of y1, first series of that solution, this solution. We have checked the convergence of only first series. Similarly, we can check the convergence of the second series, but first we have to generalize it. We have to write the general term of the series. I hope you can write it by using the similar pattern which we have used for the first series. You can try it yourself. Otherwise, you can discuss with me in the next lecture, and it's basically general form is also included in my notes. You can see them there. If you have any question, you can ask me.
इसके अंदर 1 की टर्म भी है ना?
हाँ जी.
तो जब हम इसकी लिमिट ले रहे हैं y1 of x की, तो हमें पूरे की लिमिट नहीं लेनी चाहिए. मतलब हमें लिमिट ऑफ 1 प्लस वो जो सारी चीज है डिवाइडेड बाय 1 प्लस सारी चीज की नहीं लेनी चाहिए.
देखिए, whenever we check the convergence, we check the convergence of the series. ठीक है? This term is not included in the series because it's a very different term in that solution. We cannot include it here. Okay? So we check the convergence of this series. If this series is convergent, what does it mean? If its sum is finite, then अगर उसका sum finite है तो उसमें 1 add करेंगे तो still उसका sum finite ही होगा. ठीक है? So if a series is convergent, we can add finite number of terms of in that series. This addition of finite number of terms in that series will not alter the convergence or divergence of that series. ठीक है? अभी हमने इसका सम कैलकुलेट नहीं किया कि सम होगा क्या. ठीक है? अभी सिर्फ हमने ये चेक किया है कि ये कन्वर्जेंट होगी या नहीं होगी. ठीक है? अगर ये सीरीज कन्वर्जेंट है, इसका सम फाइनाइट होगा, तो 1 अगर उसमें ऐड करें फाइनाइट नंबर में तो फाइनाइट ही रहेगा. वी आर ओनली investigating whether this series is convergent or not. Ratio test only tells us that whether the series is convergent or not. Okay? And what will be the radius of convergence, what will be the interval of convergence, for what values of x this series will be convergent. Okay? We only investigate this here. Now, if we want plot the solution of that differential equation, we can plot, for example, only the first 10 terms, first 20 terms, because we know that in a series, after a certain number of terms, sorry, the remaining terms, those have basically very minimal or very, you can say, negligible contribution in the solution. So the major terms which contribute in the solutions are first few terms, and the remaining terms, because remaining terms में आप देखें denominator में जो n increase करेगा, denominator बहुत बड़ा हो जाएगा. When the denominator is very large, then a particular term with n very large, its value will be negligible. Okay? So even if we terminate the series up to 10 terms or 20 terms, then the solution will be approximately correct. Okay? Because we cannot plot all the terms of the series. We have to plot the finite number of terms of the series. Okay? I hope you get it. If you have any further confusion, you can ask me. So this is how we solve the differential equations using power series method. I have included a couple of more examples here in my notes. You can see them. अगर आपको कोई issue होता है तो you can discuss with me in the next lecture. और बहुत सारी जो है वो मैंने examples include की हुई हैं. ठीक है. Next thing which we are going to discuss is basically हमने एक theorem existence of power series देखा था. ठीक है. Existence of power series solution एक theorem discuss किया था previous lecture में. Let's discuss an application of that theorem now. Let me clean the board first. Now let's discuss how to find radius and interval of convergence without solving the ODE, which is an application of the theorem which we discussed in the previous lecture, existence of power series solutions. For example, if we have this differential equation x square minus 25 y double dash plus 2xy dash plus y equal to 0. And we need to solve about ordinary point x naught is 0, and the second solve again this differential equation about the ordinary point x equal to 1, x naught equal to 1. Now, in order to solve this differential equation using power series method, we do the similar procedure which we have done for the previous example. We assume a power series. In first case, we assume a power series what? N from 0 to infinity, Cn x power n. And we take first and second derivative of this series, and then we insert it here. We obtain 3 series. And in what we do then, we try to combine all these 3 series by shifting the summation and exponent power of x. We need to make them identical by using the substitutions. Now, without solving this differential equation, we can find the radius of convergence and interval of convergence of any given differential equation about any point x equal to 0, x not equal to 0. Now look at this, the coefficient of y double dash. Coefficient of y double dash is what? A2 of x, and it is x square minus 25. We discussed singular points and ordinary points. Singular points are what? Singular points, we need to find singular points of this differential equation. In order to find singular points, what we do, we put a2 of x is equal to 0, and we solve for x. So this gives us x square minus 25 is equal to 0 and x is plus minus 5. Okay. Now these are the singular points. That theorem, which we discussed in the previous lecture, what that theorem tells us, it tells us that the radius of convergence of any power series solution of the given differential equation is what? It is at least the distance from this ordinary point, x not equal to 0, to the nearest singular point. That will be the radius of convergence. So the distance आपके पास distance of x naught, और अगर हम इसको x maybe आप इसको x1 x2 कह दें, इसको x1 कह दें 5 और x2 कह दें -5. ठीक है. तो आपके पास distance from x naught to x1 ये क्या है? It is 5 minus 0 obviously, and it is 5. So this will be what? This will be your radius of convergence of the power series about x naught equal to x0. Now, if radius of convergence is 5 and x naught is 0, then what is the interval of convergence? Interval of convergence will be interval of convergence is what? It is x minus x naught mod less than r. Now, we know x naught is what? X naught is 0 and r is 5. So what do we obtain here? X mod less than 5. So this will be the interval of convergence for the power series solution of this differential equation about x naught equal to 0. So interval of convergence, if this is equivalent to what? It is -5 to 5. Okay. So if we choose x1 5 or we choose -5, it doesn't change anything because the distance will remain 5 and the radius of convergence is basically what? It is always greater than 0. Radius of convergence must be greater than 0. It should not be negative. So we again put here 5 and we obtain the same interval. So this will be the interval of convergence for this for the power series solution about x equal to 0 of this differential equation. I hope you get it, and you can do for x not equal to 1 as well. If you have any question, you can ask me. I have given a couple of more examples in my notes. You can see them, and you can do some exercises from the book as well. I have mentioned at the end of these notes. Look at more examples how to combine. If we use this power series here in this differential equation, then we must obtain 3 series. How to combine these 3 series, I've explained here. Try this example and try to find the power series solution of this example. If you face any problems, you can discuss your problems with me in my office hours maybe, or you can send me an email for a Zoom meeting. I'll send you a Zoom meeting invitation and you can discuss your problems with me. Okay, you can see the solution of this example or similar examples in my notes as well. I hope you can do it now. Now we are going to start Frobenius method. Again, whatever we have discussed here, power series solution, this method gives us only the solution about ordinary points of the differential equation. Okay. Sorry. But this method fails if we want to find the solution about the singular points. in that case, what we do, we have to modify the method. Power series method, let's discuss it briefly. Power series method is only applicable to find the solution of differential equations about the ordinary point. Okay, is applicable only to find series solution. You can say series solutions about ordinary points of ODE, whatever the ODEs. Particularly, we are discussing here second order homogeneous linear ODEs with variable coefficients. Now, in order to find the series solution about the singular points, because in that previous example, in this example, x equal to 5 and x equal to -5 are the singular points of this differential equation. What if we need to find the solution about x equal to 5? Okay. Then when we put x equal to 5 here, this will become 0, and the second order term will be eliminated here. Okay. So we have to modify this power series method in order to incorporate the singular points in the method. In order to find a solution about singular points, what we do, we use Frobenius method. It is also the series method. Okay. So Frobenius modified this method in order to find the solutions about the singular points. Now, Frobenius further explained that singular points are of two types. Singular points are of two types. Number one is regular singular points. And the second is irregular singular points. Okay. Irregular singular points. What are these regular and irregular singular points, and how to differentiate between regular or irregular singular points? We know that what are singular points? Singular points are those points, we discussed this in the previous lectures. Singular points are those points where the coefficient of y double dash is 0. If we put coefficient of y double dash is equal to 0, we can find the singular points. This was the one way of finding singular points. What was the other way of finding singular points? It was basically what you do. You convert the given differential equation into the standard form. So what is the standard form of this differential equation? We divide the coefficient of y double dash throughout on both sides to obtain y double dash plus 2x divided by x square minus 25, y dash plus 1 over x square minus 25, y equal to 0. Now, we assume that this is what? This is your capital P of x, and we call it P of x minus 25. And this second one, which is the coefficient of y, we call it Q of x, and it is 1 over x square minus 25. The other way of finding the singular point is that we look at these functions P of x and Q of x. All those points where P of x and Q of x are not continuous or differentiable. Okay. Second method was what? Singular points. In order to check the singular points, what we check? We look at these two functions, P of x and Q of x, and we try to find the points where P of x and Q of x are not continuous and differentiable. Okay. Which obviously we can look here that whenever we put here x equal to 5 or minus 5, P of x will be infinity, undefined, and the P of x will not be continuous at x equal to 5 or minus 5. And there is general term used for regular singular points and irregular singular points. We check whether P of x and Q of x are analytic. P of x and Q of x both are analytic. Analytic functions. Analytic functions means what? They are continuous and differentiable. Up to certain order, okay, or infinitely differentiable means all their derivatives exist. Okay. Then we say that P of x or any function is analytic. Okay. Analytic functions are those functions which are continuous and differentiable up to infinite order. Okay. All their derivatives exist and they are continuous. So those kind of functions are called analytic functions. Okay. So analytic means पहले आप देखें continuous है या नहीं, continuous है नहीं है, किन points पे continuous नहीं है, plus minus 5 पे continuous नहीं है. ठीक है. You then, if the function is not continuous at certain points, you don't need to check the differentiability. क्योंकि अगर if a function is not continuous at a certain point, it will definitely not be differentiable at those points. Okay. So यहाँ पे P of x and both दोनों check करने हैं. Both functions should be analytic. If at least one of the function is not analytic, then we say that that point is singular point. So singular points here are for P of x and Q of x are plus minus 5. Okay. So singular points यहाँ पे क्या आ गए? Are x is equal to 5 and minus 5. Now further, we need to check whether these points, singular points, are regular singular points or irregular singular points. Okay. In order to check regular singular points, what we do? Regular singular points. Okay. Regular singular points कैसे check करेंगे हम? आप यहाँ पे एक नया function define करें. Small p of x is equal to x minus x naught into capital P of x. Okay. And another function, small q of x is equal to what? It is x minus x naught whole square, capital Q of x. Okay. Where x naught is what? X naught is singular point. Now if we consider 5 here, then x minus 5 into P of x. What is this capital P of x? This capital P of x is defined here. Okay. And small q of x is new function, which is x minus x naught whole square into capital Q of x. Capital Q of x is defined here. If small p of x and small q of x, they are continuous, they are analytic at x naught, which is singular point. If small p of x and small q of x, if these two functions are analytic at this singular point 5, then we say that this x equal to 5 is regular singular point. Okay. How do we check it? Let's check them. Okay. यहाँ पे small p of x आपके पास क्या हो जाएगा? It is what? X minus 5 times capital P of x is into 2 times x divided by x square minus 25. ठीक है. अगर आप यहाँ पे देखें x minus 5 into 2 into x divided by x plus 5 into x minus 5, ठीक है. अब यहाँ पे हम कहेंगे x is not equal to 5 और x minus 5 कैंसिल हो जाएगा, ठीक है. So it becomes what? 2x divided by x plus 5 small p of x. अब x equal to 5 पे ये फंक्शन क्या है? ये कॉन्टिन्यूस और ये एनालिटिक है. x 5 यहां पे पुट करें तो अनडिफाइंड तो नहीं होता, इट्स अ फ्रैक्शनल फंक्शन. सो स्मॉल p of x इज एनालिटिक at x equal to 5, ठीक है. Now we again check the second function q of x. Q of x is what? It is x minus 5 whole square. Okay. X minus 5 whole square into q of x. What is q of x? It is 1 over x square minus 25. It can be written as what? X minus 5 whole square divided by x minus 5 x plus 5. X minus 5 cancel हो जाएगा and we obtain x minus 5 over x plus 5, ठीक है, where x is, you can say, not equal to 5, ठीक है. Now q of x is basically what? Is it analytic at x equal to 5? Yes, it is analytic at x equal to 5. आप x equal to 5 पुट करें तो यहाँ पे 0 आ जाएगा ना, ठीक है. और 5 पे ये अनडिफाइंड तो नहीं होता, तो ये कॉन्टिन्यूस होगा ये फंक्शन, ठीक है. कॉन्टिन्यूस होगा, डिफरेंशिएबल भी होगा. सो q of x is again analytic at x equal to 5. So both p of x and q of x are analytic at x equal to 5. It means that the singular point x equal to 5 is a regular singular point, ठीक है. So it is a regular singular point. We check again. So what? So both p of x and small q of x are analytic at x equal to 5. Therefore, x equal to 5 is a regular singular point. Similarly, we can check for x equal to minus 5. x equal to minus 5 के लिए चेक करेंगे, ठीक है. x equal to minus 5 आपके पास मेरे ख्याल में यहाँ पे आई, हाँ, x equal to minus 5 को अगर आप ये चेक करें दोनों p of small p of x and q of x को, तो इसमें से कोई एक जो है वो यहाँ पे क्या आ जाएगा, यहाँ पे प्लस हो जाएगा, क्योंकि x माइनस माइनस 5 प्लस 5, तो प्लस प्लस कैंसिल हो जाएगा, माइनस रह जाएगा आपके पास, ठीक है. तो x इक्वल टू माइनस 5 पे ये मेरे ख्याल में एनालिटिक होगा, और प्लस 5 यहाँ पे करेंगे तो प्लस वाला प्लस से कैंसिल होगा, माइनस वाला नीचे आएगा या प्लस वाला नीचे आएगा, माइनस 1 से ये अनडिफाइंड हो जाएगा. तो मेरे ख्याल में q of x एनालिटिक नहीं होगा, और x minus 5 is I think is not regular singular point. It is irregular singular point. इसको आपने वेरीफाई करना है, वेरीफाई इट, ठीक है. So now we know how to check, how to investigate whether the given point is regular singular point or not. Is there a question in the chat window for q of x? Isn't it analytic at x equal to minus 5 instead of 5? Never mind, I misunderstood. Okay, no problem. I hope you get it.
Sir,
जी बेटा.
सर मेरा एक सवाल है सर, जब हम p of x और q of x में x इज इक्वल टू 5 के लिए चेक कर रहे हैं, दोनों को जब हम रिड्यूस कर रहे हैं, जहां पे हम लिखते हैं x इज नॉट इक्वल टू 5, तो हम इस फ्रैक्शन के लिए 5 को तो डोमेन से निकाल रहे हैं वैसे ही। तो अगर हम 5 पुट करेंगे तो फिर हमें ओरिजिनल फ्रैक्शन में पुट करना पड़ेगा जो कि 0/0 ही दे रहा है, तो ये तो कंटिन्यूअस नहीं हुआ फिर।
हाँ, that's you can say good question. देखिए 5 को तो हम निकाल रहे हैं, but this procedure is only to tell us whether the point is regular, singular or irregular. Regular singular point means जैसे आप removable continuity पढ़ते हैं, removable discontinuity, ठीक है। डिसकॉन्टिन्यूटी को हम रिमूव कर सकते हैं। देखें जो आपके पास रिमूवेबल डिसकॉन्टिन्यूटी की क्या कंडीशन होती है? लेफ्ट हैंड लिमिट एंड राइट हैंड लिमिट दे आर बोथ सेम, बट द वैल्यू ऑफ दैट फंक्शन इज नॉट डिफाइंड देयर, ठीक है। यही होता है ना रिमूवेबल डिसकॉन्टिन्यूटी की कंडीशन जो होती है। यहाँ पे व्हाट वी आर ट्राइंग टू डू, we are trying to investigate whether that singular point which is making the coefficient of that differential equation 0 or undefined, that is making p of x undefined. देखिए आपका जो कैपिटल p of x है यहाँ पे x equal to 5 पे ये undefined है, ठीक है। x equal to 5 यहाँ से निकल गया। 5 के अलावा हम चेक कर रहे हैं कि बाकी तमाम पॉइंट्स पे ये कॉन्टिन्यूस होगा, और 5 पे whether we can remove this discontinuity or not. If we can remove the discontinuity for that particular singular point, then we say that it is regular singular point, ठीक है। अगर हम उस discontinuity को remove नहीं कर सकते, even by multiplying x minus 5 power 1 and x minus 5 power 2, ये हम basically क्या कर रहे हैं? We are trying to investigate whether this singularity is removable or not. अगर removable है तो हम कहते हैं कि ये regular singular point है, अगर removable नहीं है तो फिर हम कह रहे हैं कि ये irregular singular point है, ठीक है। तो your question is I think right, that आप इसको डोमेन से निकाल रहे हैं। देखिए आप अगर रिमूवेबल डिसकंटिन्यूटी का ग्राफ बनाएं तो वो कैसे बनता होता है? I hope you remember that thing. Let me clean this here. Removable discontinuity किस टाइप की होती है? Whether when a function is not defined only at a single point, ठीक है, ये वाला, ये पॉइंट आपका डोमेन में नहीं होता, ठीक है। तो आप क्या करोगे? उस फंक्शन को 5 के ऊपर सेपरेटली डिफाइन कर दो तो वो डिसकंटिन्यूटी जो है रिमूव हो जाएगी, ठीक है। So this is what we are trying to make it. If that singular point is regular singular point, then by changing the power series accordingly, we can find the solution. ठीक है। यहां में देखें, अब हम फ्रोबेनियस मेथड में जो पावर सीरीज अस्यूम करते हैं, फ्रोबेनियस power series, that is something different from the regular power series. It is what y of x, we assume that x minus x naught whole raised power r summation n from 0 to infinity cn x minus x naught whole raised power n. Now where x naught is what? X naught, where x naught is a regular singular point, okay. In order to remove that singularity, okay, or removable discontinuity, what we are going to do, we are trying to, we have make an adjustment in the simple power series with this factor x minus x naught power r, where r is some constant, where r is constant, and we have to and it needs to be determined. we have to now determine this constant as well, R, and the unknown coefficient Cn. Okay, this R and this whole factor basically it helps us to find the solution of the given differential equation around the singular point. Okay, ये R कैसे find करेंगे? We again, what we do, we try to substitute this solution into the given differential equation and try to find the value of R as well as the unknown constants. Okay, how to do this? We'll discuss this in the next lecture. I hope you get it. If you have any further question, you can ask me. So I think this is sufficient for today. We stop here. If you have any question, you can ask me. We'll discuss this Frobenius power series further in the next lecture.